Hello, everybody. My talk today is going to be on refactoring, and I am calling it Gold from a Monolithic Legacy. This talk is going to be filled with a whole bunch of maybe bad puns. You might get them, you might not. Feel free to groan or laugh if you like. I'm just going to be going over the basics of what I think are good ways to go ahead and refactor your code bases. Welcome, thanks for coming. Hope you're enjoying the food. My name is Doji, and I am a Techlahoma volunteer. I am one of the core organizers of the OKC Design Tech Group, where we're trying to promote UX education because it's really important. It goes hand in hand with development. You don't have good UX design, you don't know your users, you don't know how to tie that to business goals, your development can slow down to a crawl, it can make lots of problems. So we feel that that's very important. Additionally, I am also the local leader for a group called the Interaction Design Foundation. If you're more into learning about UX design by yourself online, you can go there, you can check out their courses. They have a whole bunch that you can check out. I am technically a DevOps engineer at my company right now, but I associate more as a full stack, do anything programmer. If you toss me into a situation, I'll figure out a whole bunch of languages, cobble them together, and go with it to try and get my solutions through. That's why I feel that I can give this talk. So the topics for today, this is what we're going to be going over. First of all, some misconceptions about software development. A lot of you have been in this game for years. You have war stories. I have war stories too. But a lot of us have some misconceptions, and I kind of want to go through and fix those, maybe think about things a little bit differently. I'll go over some terms and definitions. Might be familiar with them, but it's good to get up to speed on that. After that, I'm going to talk about monoliths and their legacy. I'll tell you how you can break down a monolith. We'll look at the macro and micro view of that. I'll talk about going CLI first, so command line, because if you go command line, you have a lot of flexibility, even with GUI applications, surprisingly. And then I have some recommended resources as well. If you have any questions, please write them down or think about them, and at the end of the talk, we'll go ahead and I'll try and get your questions answered. So let's go on. So really quick, let's go ahead and define what some of these misconceptions are. Over here we have a road. And a road can mean lots of things. If I started out throwing out ideas, we have the road to righteousness, the road of life, a pathway to destruction. Lots of different ways we can describe this. I'm sure that if right now you think about it, there are lots of different metaphors you can get out of this picture with a pathway going somewhere. Life is a journey. This is your pathway to whatever destination it is. In other words, metaphors have power. The metaphors we use to describe the things that we do daily to people who might not understand the intricate details of what we do are very important. And we have to be careful about how we use them. We have lots of metaphors in software development. This one, everyone familiar with this metaphor? Software construction, that's a metaphor. We're software engineers. The waterfall method, development. Here's that engineer. And here's one. Does anyone have a guess as to what metaphor this is? Technical debt, that's right, technical debt. We have technical debt as well. So these are all metaphors we use to understand our industry. Now let's look at construction really quick. We get construction from this. We've been doing construction for over 10,000 years as the human race. It's really awesome. That's how far we've been. The Egyptians used to do it like this. They used to build these big, gigantic structures. Last year's, you can still go and look at the pyramids. Now we've modernized, we've put in safety standards, You can't beat people to work for you anymore. There are lots of other things that you can't do, right? But we still build buildings. And we could build pyramids. It's just cost prohibitive. We can't justify building something like a pyramid that's that big. But you look at this and you say, this is construction. Now, if you think about construction projects are usually measured in years. It depends on the construction project, obviously, but several years. Maintenance occurs in periods of years. So you build a building, if it's brand new, for the most part, you don't think about doing any maintenance on it until something breaks a year, 2 years, 3 years down the line. And depending on the building, it can last several years. This is the Taj Mahal. It was constructed in 1653. They do maintenance on it. They clean the outside. It looks good. But for the most part, it's a structure. It's been built. It's there. And that's what it is. Construction projects have a definitive finish. Now, we use this metaphor to talk about our industry, software development. Let's look at software construction. So as an industry, software construction or software development is less than 70 years old, unless you include Ada Lovelace and her calculating machine into the whole thing. Other than that, it's less than 70 years old. Construction is measured in weeks and months for us. You have 3-week sprints, 3-month projects, yet the expectation for the projects that we work on is they should last years. You spent all this money to build the project, you built the project, we expect it to last years, and then it goes into maintenance mode. All of these metaphors that come from construction. But when you think about it, when it comes to comparing software development to real-world construction, we are still in the dark ages. This is what we do. If anyone's been on a death march on a project, this is what it is. We don't have the technology there to get there. I see somebody laughing in the background, got it. You've obviously been on a death march. Okay. So maybe we should start thinking about software differently. I'm going to present you a different idea. It's not my original idea. I read tons of books. I'll tell you the book I got it from in just a little bit. But what about this metaphor? Gardening. We've been gardening for over 10,000 years, equal to the amount of time we've been doing construction thereabouts. It's measured days, weeks, and seasons. Maintenance changes according to the circumstances, and there's no definitive finish. You're not ever finished gardening. You always need food, you always need to eat. You're always finding ways to improve your yields. It's an ever-changing landscape. If you think about it this way, you plant your carrots, you plant your tomatoes, they start growing, and then 3 days later, you have birds. So what do? You put nets up over for your birds to keep the birds out. You put up fencing so that the rabbits can't get in. You put deterrents so that the deer can't get in and eat your stuff. Maybe you get fungus infections on your plants, whatever. You always have to take care of these. There's constant maintenance. It's just like our software systems. There's a bug. The API changed. Now we need to change out the API. Oh, the customer wants this now, so we need to change it up. It's the same. And the time that we spend doing gardening is kind of equivalent to the time that you would be doing software maintenance projects. So this is probably a better metaphor for what we do. It comes from the book, Making Microservices. I'll introduce the book at the very end. And it was Sam Newman's idea, and he said that basically software construction is prohibiting us from moving forward. I worked at a company where there was an industrial engineer, and every day he'd come by my office because I helped him with automation on his warehouse machines, and he said, "How come you software developers are always working on the same project?" I'm like, well, he approaches it with that construction mentality. It has to finish, and then it's done, and you maintain it. But we're gardening. We're always curating it. We're always changing things. You should go through and refactor, just like weeding. That's what we're doing. So this is probably what it is. When you're doing this, you're typing at your keyboard, just like the guy over there to the right doing his gardening, you're doing your digital gardening. Roses, rose bushes, they look beautiful. They're awesome. Until they get out of hand. Has anyone dealt with an out-of-hand rose bush at their house? Or seen an out-of-hand rose bush at somebody's house? I see some nods, yes. Okay. Imagine going into that code base that's just terrible. This is what it feels like, right? Dealing with thorns, it's painful. You got to get the gloves on. You got to go into it. So this is probably a more appropriate metaphor. Now, really quick, I'm going to go ahead and take you through some definitions, just so that we're all on the same page. First one, technical debt. We talked about this just a little bit. And it's basically using bad shortcuts to get the job done. Failing to clean up after you've finished a project, whether it's not having the ability to refactor, not having the ability to break things out into modules, and like I said, not stopping to refactor. Refactor should be built into these cycles, these 3-week cycles, 4-week cycles that we're doing our development in. And as technical debt increases, the ability for us to change the software system efficiently, effectively, and in an expedient way decreases. So it's very, very important to manage this technical debt. Otherwise, you're just paying off the interest, and you're not paying off any of the principal. Eventually, you're buried in it, and the only thing to do is rewrite the system. We'll get to that in a little bit. Next is monolithic architecture. Now, monolithic architecture and legacy systems are not the same thing. We have a monolith. I should have cued the theme from Space Odyssey 2001 for this, but I didn't. You can play it in your minds. There's the monolith. It's awesome. And that's a system where you say, hey, we need logging. Let's toss that in there. We need UI display. Let's toss that in the same solution just because it's there, it's easy, it's not going to get that big for now. You need database. We need to communicate with the database. Let's toss that in there too. It's okay. It's not that big right now. User interaction, yeah, we need a little bit more of that. Let's toss that in there as well. You know what? Let's just toss everything in there. We don't have time to refactor and break things up. Everything goes into the same system. Everything is in the same place. That's a monolithic architecture. It's not necessarily bad, but right now in our current state with where we're at with development, it is prohibitive. Legacy systems. Now, a legacy system is basically a business-critical system where it's in production, there are few tests, so you can't really test out how behavior is going to change, but it's business-critical, so you always have to keep it maintained. And Michael Feathers, in his book, Working with Legacy Systems, really talks about this. Once you can get a test suite around it, and he's not necessarily talking about unit testing your individual functions, but testing the whole system where you know this behavior produces this kind of output, then you can migrate off of your legacy systems onto something different. So you should be thinking about testing from more testing the whole system instead of unit testing. And he's not saying that you shouldn't unit test. He's saying differentiate between when you should be unit testing, when you should be integration testing, and when you should be full system testing. It also goes into DevOps just a little bit as well. Microservices. Everyone's pretty familiar with that now in this climate, but you have microservices where you'd have one thing that does one thing only, data visualization. We have a robot that does data visualization. Awesome. We have another one that does reporting, another one that does our UI engine. You can call on any one, you can get what you need, and you can integrate it into whatever solution you have, but you're not 100% tied to them in having to integrate them directly into your own solution. Next, software seams. Now, you might not be familiar with this one, but if we can look at the background where we see the quilt, software seams are kind of like that quilt. Not as pretty. We've heard of spaghetti code. so the seams are not that great. But software seams are where two different systems join together. That's an opportunity for you to break apart the system for the good of your business. If, for example, you can offer your reporting system as a standalone single offering to your customers, refactoring has value. Removing that from a big monolithic solution has value. You can price it, you can get value back, it can stand independently alone, and you can get off of this monolithic system. Anytime you see a software seam, that's a chance to refactor. So think about the quilts, think about the seams. These are places where you can go and refactor your projects. So having said all that, we know where we're at with metaphors. We talked about some terms that are also metaphors as well. Let's take a look at monoliths and their legacies. Now, first, I kind of want to say, how do monoliths come to be? A lot of times, it does come from overutilization of developer resources. Because of the way we push through the industrial age till now, there is this thinking that if you're not constantly, consistently producing, if you're idle, then you're not productive. But we work on computer systems. We know that we don't want our computer systems to be 100% utilized. Who's run on a system that's 100% utilized in any way, shape, or form? Was it fun?
Oh, it was hellaciously fun.
Not fun at all. I brought down a whole factory once doing a logging system. 100% utilization. Couldn't even log in to stop my processes. You don't want 100% utilization. Developer resources are the same. When developers have downtime, they're going to find things to improve. So that's one way that monoliths come to be. Well, we need the next feature, we need the next thing, we need the next thing, we need the next thing. No downtime. Another one is poor definition of business goals and user needs. And you've all done those reworks where this was the way it was spec'd out to me. I built the system that way. This is how the UI came out. This is how the logic worked. This was the user flow. And after you've put it into production, your manager comes and says, yeah, it doesn't work. It doesn't work. But it's not it doesn't work, it's the user wants something else. Or it was working for the user, but it's not tying into our business goals, so we can't make money off of it, so we need to change it. It's usually one of these things. So you just change things and make workarounds and fix it to be the way it should be. Feature creep. We've all had feature creep, feature creep. Let's just toss everything in. Once again, that monolith. And the last one, and this is where we start seeing where we can possibly break apart a monolith. It's lack of package management. If you start embracing package management, those are opportunities for you to find those software seams, break apart the architecture, and say, this is its own thing, it stands in isolation, we can use it that way. This is an image. I don't know why I put it here. Besides the fact it's a car that that would be a rad car to drive, actually. That's pretty cool. Props to whoever did that. If your systems feel that way, like they oftentimes do when you get a monolithic system, then maybe you need to do something. You can see the seams on this car. That's like a 1930s Chevy truck or something like that, and a Pontiac. Talk about legacy. They don't even make Pontiacs anymore. Where'd you get the parts for this thing? So this is warning signs that you're growing a monolith. I should have named this slide, this might be a monolith if, like Jeff Foxworthy, but I'm good. If you have more than 3 projects in a solution, it is most likely a monolith, or it's going to get there. So we work with solutions a lot. Who has more than 3 projects in their C# solutions? Almost everybody here, okay. If you could kind of whittle that down to less than 3, that would be ideal. Another one, all or nothing compilation. So you can have lots of projects in the same solution. Can you compile one project and one that run one project, or do you have to compile the whole entire solution? Who has to compile the whole entire solution for everything? Okay, one. That's it? Everyone else is good? Another back there, okay. Little to no code in package management. Does everyone leverage NuGet? And not in consuming other people's packages, but in building your own packages. Who builds their own NuGet packages? We got one over there. I've built quite a few packages. Once you build them, it's great because you can push them out to your own private repository and then pull them back in on a different system. And it works just like any other NuGet package solution. It's great. Product features are accessible only through the GUI. So you have a GUI application. In order to test this one thing, the only way you can do it is through the GUI. If that's the case, you most likely have a monolith or you're starting to grow one. All or nothing project scope. So today you're going to be working on a feature for the user where if they double push a button, it submits their transaction twice, so you need to go ahead and make sure that double clicks are successfully intercepted, and it only gets processed once. You jump into that project, all of a sudden the whole entire solution is in project scope because of spaghetti code. Most likely you're working on a monolithic solution. Deployment is all or nothing. So you can't just deploy one piece of the puzzle, one piece of your binary out and change it. You have to deploy the whole solution. You have to tell all your users, update the whole thing. If that's the case, then you're working on monolithic code. And finally, you can't release code on commits. Yes?
I'd also add if they're sharing the same database, data layer. So that's a problem I have. I have different projects that can be deployed separately, but you make a change in the database, and now they all have to have an entity framework, so therefore they're all tied.
Okay, so I missed one that was brought up just now, and I've actually talked about it quite a bit at a company I worked at before, and I missed it for this presentation, but it's really good. Even though you can push out all of your code out, it's independent, but they all share the same database and the same database structures, they don't have their own separate databases, then it is 100% a monolith. And that's something that I didn't bring up in this, but since it was brought up, I want to talk about that right now. It's very important to try and separate out that database architecture in some way, shape, or form. Later on this solution, this presentation, I do talk about JSON. JSON as a communication framework, because you can share data that way. It doesn't have a set structure, but you can get the data you need when you need based on that. And that can be a partial solution to the database. But if they're communicating directly to the database, it's the same database, they're hitting the same thing, it is 100% a monolith. Let's talk about the legacy of legacies. You guys all know this. Once you're working on a legacy system, it slows down forward movement for the company because you're on old technology and you have to maintain it. It's business critical. We've already talked about this. It's business critical. It slows down forward movement because you can't change it. Every push to change it is met with equal pushback saying, we can't change it because it'll affect our customers, we'll lose our customer base, we don't know what it will break. It requires ever more developers. If you see your managers tossing more developers at the problem, then it's usually a legacy system. It makes it difficult to find fresh talent. Now, there are recruiters back there. I'm going to say something kind of, I don't know how they're going to feel about it, but I'm going to say it anyway. Anytime you see a job listing that says we need developer on X framework, archaic framework, that has 10 years of experience doing X framework, doing it with these archaic technologies all stacked together in the same solution. Most likely, they made a mistake of making Joe angry, and Joe found another job, and they just want Joe back. But they're not afraid, they're too afraid to say, hey, Joe, we'll give you a better job, and we'll help you break it apart. And instead, they're looking for that developer that's Joe, but not Joe. You don't want to get into this situation. It increases onboarding time. New developers can write really good code. However, you toss them into a monolithic system or a legacy system, and all of a sudden they're not being productive from the get-go. And that's because you have to learn the business culture, you need to learn the business silos, you need to learn all the rules, the undocumented rules, where everything is. They might start to rewrite things that already exist, but they don't know they exist. How do you know what you don't know? Who was the guy who said they're known knowns and unknown unknowns? That's where they're in. They're always in the state of unknown unknowns, forging new ground that's already been plowed by somebody else. And potential for complete loss of system knowledge. Joe left the project. We need somebody that has 12 years of experience. It's that situation. Talking about legacies, does anyone know who Alan Cooper is? You do? Awesome. There's some people who know him. Great. He is a UX designer, user experience researcher who is famous for inventing a language called Visual Basic. This guy made it. And I went to a conference last year in Dallas. It's called the Big Design Conference. He was the keynote speaker there. And he gave a really good keynote presentation about how there are lots of issues in society, there are lots of issues that you're going to be dealing with, whether it's software development, user experience design, et cetera, that you're going to have to tackle. And a lot of them are messes left by people that had to do the things to get your business to where it is right now. And this is a paraphrase, but it was pretty powerful. He said, "You didn't make the mess, but it's your responsibility," I messed up my apostrophes, sorry about that, "to clean it up. It's your responsibility to clean it up." I was at that conference. He opened the floor to questions. I raised my hand. I asked him a question that I wish a lot of you would also get the opportunity to ask. I said, "You said that it's my responsibility to clean up messes that other people left. I've been working on VB6 solutions for a long time. VB6 is very painful. However, I am looking at the guy who's pretty much directly responsible for the messes I'm cleaning up. What do you have to say for yourself?" It's pretty epic. He said that he developed it as a solution for prototyping user interfaces so that people could do user interfaces quickly and get a kind of an idea of how the interaction should work and get it to a programmer. That was the goal. So he's not responsible for what happened to Visual Basic after he sold it to Microsoft. That was his answer to me. He did seem a little flustered, though. I got a picture with him afterwards. And I thanked him for getting me the job, because a job is always a job, and you do it anyway. So, if we're going to break down a monolith, we need to have a strategy to get it done. We're going to look at the micro level first. It's pretty much this: read clean code, and then you're done with all the micro level. How many people have read clean code? More people need to read clean code. It is a great book, amazing. Robert Martin. And if you have a chance to see any talks from Robert Martin on clean code on YouTube, you should. He's a very angry developer, but he's a very intelligent developer. He's awesome. He has a lot of knowledge to impart. But it's because of that rage, because of that anger, because of that knowledge, because of his experience, that is great. He likes to say, "Mic drop, I'm done, clean code, it's all good." This is a very good book. There are lots of famous search companies that use this as part of the entrance to their company as well. So it's very, very highly regarded. However, to give you an overview of what it is, first and foremost, you want to make sure that you're avoiding magnet classes. If you have a class that is the toss everything into class, then that's a sign that you're going someplace that you don't want to be going. Maybe you have a common library. Everyone has a common library. Like, it's just common, let's toss it in. You have to use a lot of discretion when using those common library classes. You also want to keep classes and functions shorter than you think. So if you think your function is short, your class is short, it should be much shorter than that. You want to use long, clear names and avoid deep conditional nesting. So nesting over, if you can keep nesting to less than 2 levels deep where possible, it's ideal as well. And that's one of the concepts he talks about in the book. You want to keep your function parameters to less than 3. He says, if you have 3 function parameters, you should think really hard and well before tossing in that third. Take that away, you have 2. If you have 2 parameters, you should think very hard and well before adding that second one. Ideally, you want 1, if possible. You also want to avoid void. You want to return something from your functions. This comes back to unit testing. If you're always returning something, you can unit test it. It's really easy. If you always have to check the state of the object, then your unit tests kind of fall apart. But if you can, in isolation, hit each one of your functions, if a function looks like it could be run statically, don't make it a static function, but if it looks like it could run statically, then you have a very solidly built function. Additionally, you want to approach code health objectively. We have a lot of opinions about this. I have my own opinions. I have an opinion that I can say right now that would make everybody really angry. I love tabs. But every place I go uses spaces, so I use spaces. It's all good. That's an opinion. But objectively, there are things that can help you out. For example, SonarQube. SonarQube is static software, code-based analysis tool. And what it does is it tells you where you have deep nesting, where you have code that's just dead, it's not referencing anything, where you have commented code that should be deleted. It helps you make the case to go to your managers, to go to your project managers, project owners, and say, hey, if we improve our code here, we can improve our productivity over time, we can reduce technical debt. There's one metric, and I couldn't get it over here because I don't have a running instance of this at home, but there's a metric where it tells you about cognitive burden and cognitive load on developers. The more you nest, it gives a plus score to cognitive load. Because as you're diving deeper into those functions and you're thinking like, okay, so it was if and it's this case, you're putting more burden on yourself. Those are the days whenever you've seen code that's nested in for loops and nesting in for loops and nesting in for loops, and you go home and you're like, I'm so tired today, I just want to sleep. You've exhausted all of your cognitive resources, and that's why that's happening. So if you can approach it with something like this, that would be excellent. So this is the micro level. What I'm really here to talk about is the macro level. Now, most of the time, what's going to happen is you have a legacy system or you have a monolithic system, and everyone says, hey, let's rewrite the whole entire thing. It'll be better. It'll be greater. It'll be faster. It'll be stronger. It's usually a bad sign. You don't want to rewrite your legacy systems. You don't want to rewrite your monolithic systems. This is talked about in the microservices, working effectively with legacy code, and in clean code as well. They all talk about it. Don't rewrite the systems. Find those seams in the software and work from there. And the reason that they say that is dangerous. You're wasting time developing something new when it already exists, when you can just clean it up. It also promotes knowledge loss. If you start writing again, there are all of these issues that you hit organically, that you solved, that you're going to hit again and resolve again when they've already been solved. All you need to do is take them out, clean it out. Additionally, it's slow to market. It's the whole construction paradigm, construction metaphor that I talked about earlier. It's not gardening, it's construction. You say, we're going to design everything, A, B, and C. It's going to take a year and a half. These are the resources we're going to allocate to it. These are all the resources that we need on the database end, the back end, the front end, the developers. This is how long it will take. It's really slow to market. It takes time, and in the end, when you're on that death march on this new system that was awesome and now a monolith itself, you've wasted time getting to market. And it will probably spawn another monolith. So you don't want to do that. Once again, it just goes back. Thinking with the gardening approach. In a garden, sometimes with rice fields. They plant the rice someplace else. Then when it's big enough, they transplant it. It seems like you're doing it twice, but you're actually doing it the correct way. It has to have an environment to live in. Once you know what it is, what's good, what's bad, you can plant it someplace else. We do it with trees. We'll plant them, we'll transplant them someplace else. You do them with your own plants. You'll take them inside, you'll take them outside. You split up plants. They're plants that, in order to make them reproduce, you'll say, hey, here's my plant, I'll split it apart. So now I have two. I can plant one here, I can plant one here. Spider plants, you do that as well. Seams, splitting things apart. This is where you get the gold that I talked about in this presentation from your system. If you have a legacy system or a monolithic system, you're sitting on a gold mine. It's all the knowledge that your company has accrued over all the years that it's been there. You just need to get it to a new architecture, and you can do it in parts. There was a joke about The Pen is Mightier by Sean Connery, where he says something like, you're sitting on a gold mine, Trebek. Take a dozen, or something like that. I'm thinking that same thing. Anyone who's like, I'm just going to get rid of my monolithic system and move to something else, no. That's the gold mine. You want that. You want to get everything you can from it. So basically, you go into package management, you start using things like NuGet. You want to use that as much as possible. NuGet is a great way to split apart your system, and you can consume it in other areas of the company as well. For anyone that hasn't done it, you can set up your own private internal company NuGet repository. A lot of companies are afraid that NuGet means putting it out on the web for everyone to see, but it's not that way. You can use your own security measures to put it in your own company within your own firewalls. I've done it. It works. You want to break projects out of the same solution. Wherever it makes sense to, break them out, break them apart. You want to keep a repository of your build artifacts, so the binaries that you create, the DLL files you create. The reason is, once again, when it comes to DevOps and deploying things asynchronously, once you have things, your repositories, once you have a repository of your build artifacts, you can push that out. You can pull that out as well. You can say, if I use binary 1 or binary 2, it doesn't matter. I can push them out. I don't have to compile the whole thing and make an installer, etc. And migrate to a distributed version control system if you haven't. Hopefully, is there anyone that's not on a distributed version control system at this time? Okay. You're getting there. Good, good. The sooner the better. Baby steps, 100%. Now here are the common objections to refactoring or splitting up a monolithic system. They break down into business, pricing, and organizational. With the business side, it's productivity metrics. If we start refactoring, then we're not building new features. And new features are what bring in the money. But like I said with my slide on the quilt and the software seams, if you're able to pull out your reporting module and offer it to your customers as its own offering, you don't need our entire $3,000 solution. You can pay us $30 a month, and you can see the reports that parent company this generates. You've now made value for your business. They also don't see the overall value in refactoring, because usually for us, refactoring means going and making the code look pretty, adding tabs. No, but they don't see that. And because of that, they have a lot of objections. Pricing. There's no way to charge the customer if you're just making the code look pretty. However, there is a way to charge the customer if you've made a separate offering that stands alone by itself. Dev time is expensive. It is 100% expensive. However, if you have smaller separate solutions and project scope is small, you can attack problems in less time. You also have to think about Conway's Law, organizational. This is organizational, where your system is going to grow the way your company is. The way the organization is laid out is the way your system is going to grow. So where you have silos or bottlenecks in your own company as a culture, that's where you're going to see the silos and bottlenecks in your system. If you can address these with some of the ideas and methods that I've presented pushing forward, I feel that businesses do have value to gain from refactoring. Let's go ahead and take a look at the CLI. So I talked about breaking things apart. I talked about testing a whole system as a whole system. We kind of need to make a paradigm shift to thinking CLI first. And that's because the CLI is very, very, very flexible. You can integration test it. You can unit test it, in a sense, because you can test the branching by sending code to whatever your command line parameters are. You can toss a GUI on top of it. Let's take a look at that. Now, I get this because I've worked on lots and lots of systems. I worked with Linux. I love Linux. I love C#. The only thing I wish is that Windows would change to a Linux base, and then C# would be amazing, and then we're all done. The reason is Linux is pretty amazing. Does anyone have any idea why Linux might be pretty cool?
Piping, filtering.
What?
So the programs, how they pipe into each other and filter.
Exactly. Piping and filtering between programs. On a Linux system, anytime you have a program, the system gains value exponentially. Every program can talk to that program. You can set limits, you can set restrictions, but any program that exists there, everything can talk to it. Imagine if on a Windows system, and Adobe's not going to do this, but imagine if you could use an Adobe backend because Adobe exists on your system, and you know that. And you just make command line calls to generate a PDF through Adobe because Adobe's on your system. That's what CLIs do. That's what makes Linux really amazing. It's very loosely coupled. Threading is easy. If you've ever been in the threading deep hole where you're like, I'm working with threading in my own solution, if you've tried threading with external executable programs, it's really easy. Spawn process, done. It takes care of itself. The OS takes care of the rest for you. You don't have to worry about it. You can find out whether the process terminated. You can find out the error codes. And you can also do forward compatibility. I worked on VB6 systems, and we lost the ability to use the MAPI client to send out emails. I spun up a whole bunch of, I made an email program database in C#. VB6 can call it. That's pretty awesome. So you have forward compatibility right there. It's already separate from everything else, and it just calls it right there. You don't need communication frameworks. You might be thinking, well, if I have all these processes, I need fancy communications frameworks like the Microsoft Windows Communication Framework. You don't need that because you can just manage these. If you manage your return codes, manage your standard output and standard error, you can get there very easily. Make sure your standard output's always clean. Make sure standard error is always clean with your programs, and you can always transfer information that way. But maybe you need structures. You need something a little bit more complex than that. Well, then there's JSON. JSON will get you a lot of the way there. It's flexible, it's portable, you can compress it, you can encrypt it, you can consume it via the command line, you can pull it in as a string, you can extract it, you can deserialize it, and now you have your object in a different place. However, that one program wants it. This program might have it as class B. This program might have it as class X. It doesn't matter because they communicate with JSON. It provides a lot of compatibility. And then on top of that, you want to create GUIs for your CLIs. So you want to have a CLI, and then you put a GUI on top of that. but you don't tie them directly together. You just make the same assumption, like the Linux assumption. If the program exists as a binary, if it's in my path, or if I can find it through a search to get to that path, the right version, I can make my command line calls and do everything that I need to do. And the UI is just the pretty thing that sits on top of it. To illustrate this point, I took a screenshot of the processes on my computer. And you can see that a lot of these processes spawn other processes that just sit and run. And here's the command line. If you go into your process manager, right-click at the top, click command line, you can go and you can research this. There are lots of companies that are already doing this, big companies. Adobe has all these programs that are just running and they spawn other programs. It's not this one program. Lots of programs communicating with each other. And it got cut off, but Firefox does that, Chrome does that as well if you take a look. As for the illustration with the GUI, over here we have SourceTree. Some of you might be familiar with it. SourceTree for the longest time, I think it downloaded Git. It would install Git for you, but it wasn't embedded in SourceTree. It would call Git that way, and it's just a CLI on top of that. It just assumes, hey, you have a CLI, you can communicate. We all use Git. A lot of us use Git. You can send Git commands. It's really easy. You can test out Git, and then you can also test out your UI. Really good there. To end everything, I really like to say that it's probably all about embracing impermanence. Gardens are not permanent. Construction, that metaphor is permanent. You want it to be there forever. By embracing impermanence, you can really grow out of this monolithic mindset into something where you're working with microservices or microprograms or smaller units that can stand on their own. And I'm taking this from another presentation, which was pretty awesome, but living things grow, change, and die on the regular. Right now in your body, there's cells dying. There's cells growing back. It happens all the time, but you are still you. And you're still you because of that. You can break your arm, and eventually, it's good. We're not like lizards. We can't lose a tail and grow one, unfortunately, but we're pretty resilient over time. And I don't think the garden of your system should be any different. It should be the same. You should be able to say, hey, this part of our system isn't working, let's kill it off and replace it with something else. It shouldn't take a whole bunch of debates. It shouldn't take a committee. It should just be able to happen. And it's only by embracing smallness in your systems that you can get there. I'm going to end with a bunch of resources. Really quick, this is my recommended reading list. I talked about clean code, building microservices, working effectively with legacy code. These are some that you really, really need. However, the next one, the DevOps Handbook, even if you're not a DevOps engineer, even if you don't have DevOps in your company, you should read this book. And not just read it, be ravenous with it. I have the book right here. Those are tabs. I read through. I have highlights everywhere. I can go through and talk about it. Love it. It talks a lot about breaking things out of these monolithic systems. They talk about how Facebook did it, how Etsy did it. They had their systems where it was at this point where one change would break the whole entire system. Everything would come crashing down, and they went through and said, we need to break things apart. Another one, the 12-factor CLI apps. That's a really good language for developing command line interfaces where everything has a very consistent model. So you know where to find something. It would help a developer find out how to use the CLI. It helps testers test your CLI that would be interfaced with a UI as well. It'd help to ensure that your separate programs are consistent across the organization. And then finally, the Free Code Camp article on migrating from monoliths is also really, really good. If you have time, go ahead and watch these. It's how to build systems that survive. It's pretty much a 1-hour talk on what I just talked about on things grow and die all the time, and your system should do the same for health. If you can check out these people as well, Martin Fowler, Robert Martin, and Gene Kim, they are great people in the industry. They have a lot of information for us that can really help. Seek them out, their blogs, their books. Great stuff. And finally, if you want to talk to me about your monolith, you're working with one, and you just want some ideas, you want to bounce some ideas off of me, you're in a place where, hey, maybe we can brainstorm something, contact me. There's my email address. I also have an example project on GitHub where it is C#, it has a back end, a database manager, a front end, and a different front end. The two front ends are GUIs that are also CLIs that communicate across each other with JSON. There are errors in the code because it was an example and I wanted to show how a DevOps full chain would work with test management, etc. If you have trouble with it, let me know, I'll hook you up. So the legacy of your monolith is the gold you mine from it in new opportunities to refactor. Remember that. You have a lot of opportunities. It doesn't throw the whole thing away. You can migrate off of it. Thank you very much. Does anyone have any questions? Yeah.
A lot of the monoliths that I've worked with are a lot easier to deal with whenever they're in relatively recent programming languages and technologies that are still actively developed.
Yep.
How would you approach something with technology that's long been since dead? You know, a 15-year-old system, a 20-year-old system. I mean, I recently worked on one with like flat files, and it's like, how do we start from here to start to get away from that larger system?
So one point, like I said, with VB6 is very, very, very much dead. But there's still places that develop with it, unfortunately. You're not going to get a new IDE to help you with it. It's very, very painful. It still uses the old COM framework. But with forward compatibility, if you really do look at from the CLI perspective, in this legacy system, we can make almost all programming language can call the system somehow. You can make a system call to a command line and you can say, run this for me. And that would be a slow way to start getting there to a newer system. And I've had that pain. That's a very, very valid argument. So the question was, just to restate, if the monolith is built in a new language, it's very easy to deal with, but if it's in an archaic language or an old language, it's hard to deal with. And like I just said, it's very, very manageable if you're able to call other programs through the command line. It's whenever you get into direct integration that it becomes difficult. And the insistence on direct integration and pulling everything in is what's going to make it very, very difficult. There will be things that you still need to do there, but you can slowly migrate away. Flat files as well. There are strategies that you can deal with that as well. But once again, once you put in a newer part where it's not 100% linked to the original, then you're good to go.